Alright, let's look at the theorem 2. Saccheri Legendre theorem. Right? So it says that in triangle ABC, angle sum is less than or equal to 180. So it cannot exceed 180. Right? As you know, in Euclidean geometry, this should have been an equality, so it's equal to 180. But with the axioms we have so far, this is the best we can do. Alright, so let's try to prove that. And I'm getting lazy here. I'm going to do a picture proof. Alright, so let's say you have start with a triangle ABC, any triangle. Alright, then I'll do the angle sum preserving construction. Right? So first, I'll try to do it by contradiction. Let's assume, so I'm going to assume that the measure of the angle, we found a triangle, so that the angle sum exceeds 180, right? So which means that there exists some positive number t such that measure of the angle A plus measure of the angle B plus measure of the angle C is equal to 180 plus t. Right? So we have that. Alright, so what we're going to do is we're going to do angle preserving construction. So again, so we take the midpoint and they construct a new triangle. Remember that this construction does not will preserve the angle sum. So I'm going to call this guy A1, and this angle I'm going to call it say theta 1. Right? We know that by using the congruent triangle, this angle is actually theta 1 too. Right? Then we'll do the same construction. So pick the midpoint, then create another triangle like that. Right? And that'll be A2, and this is going to be theta 2, and this is theta 2. Alright, so you can see that you can keep on doing this process forever, right? So we know that the theta 1 plus theta 2 plus, and you can just keep on adding theta 3 and so on, but this will never exceed angle measure of the angle B. So this is less than equal to measure of angle B. Right? So which means that since you are adding infinitely many angle measures, at some point there should be some theta n such that theta n is strictly smaller than that t number. Right? T is a positive number, so we just find a theta such that it's smaller than t. Right? Then if you look at, so I'm gonna just draw a triangle. So you just keep on doing it. I need a little bit more room. I'm gonna just go ahead and draw it here. So you have a triangle. So last one. So this guy is AN. Sorry, I'm writing over the writing. And this is going to be theta n. Right? Let's focus on that triangle right there. Right? Remember that the angle sum is preserved. So if you do a measure of the angle, let's see, AN, BC, and measure of the angle ANCB. Right, so those are these two guys, right? Plus theta n. It should be exactly the same as 180 plus t because this is an angle sum preserving construction, right? Then I'm going to subtract theta n from both sides. So here, theta n, right? we know that the t is larger than theta n, so this is going to be positive. So we know that 180 plus positive, so it's just strictly bigger than 180. Right? And this is the contradiction, because remember that there was a corollary of exterior angle inequality. We said that the sum of any two sum of the measures of any two angles is always strictly less than 180. It's actually, we're saying that it's going to be greater than 180. So this is a construction, right? So therefore, the initial assumption saying that the angle sum could exceed 180 was false, right? So therefore, we know that the measure of the angle A plus measure of the angle B plus measure of the angle C is always less than or equal to 180. Right? That's it. I hope that this was clear.